So we have a task 4 now, which is also from your midterm exam. So here the question is, some data was collected while a rocket is taking off. The data collected is summarized in the table below. So we are given time and velocity of the rocket, and a linear regression model is given to us that can be fit to the 3 data points. So calculate the coefficient of determination here. So let us start doing that. So the coefficient of determination is r squared, and the formula for it is s sub t minus s sub r divided by s sub t. So first let's work on finding out the s sub t here. The formula for s sub t is equal to summation from I is equal to 1 until n. So we have 3 data points, so the n is 3 of the velocity minus the average velocity. So the velocity at each I minus the average velocity. So let us write here all the velocities down at first. So now here we'll write down the velocities, which are 106.8, 177.2, 279.2, and then the average velocity we have to find out. So the average velocity would be, let's write it here. So the average velocity would be summation of all these velocities given to us divided by the number of velocities given to us here. So that's 3 data points, 3 velocities, and that is equal to 187.733. So that's our average velocity, and now we have to do is we have to take the velocities here minus the average velocity. The formula for the sub t is also squared here, I forgot that. So we have here the values. When you subtract from each of these velocity 106.8 minus the average velocity 187.733, you get the value as minus 80.933 minus 10.533 and 91.467, and then we will square all of these values here. So the squared for each of these values will be 6550.15, 110.944, 8366.21. So then now we can find out the s sub t, which is a summation of all of these values here. So which is equal to, the total is equal to 15027.304. Okay, so that's s sub t for us. So we can say that s sub t is equal to 15027.304. And then now we'll try to find out S sub r. So S sub r is equal to the summation from I is equal to 1 till n, which is 3, of all the residual squared. So all the residual squared. So let's find out the residual. And to find out the residual, the first thing we need to find out is all the y values for the given x values here. So the x values at the time values given to us here, so those are up here, 5, 8 and 12. We will input these values 5, 8 and 12 into this formula given to us over here, which is 24.6757 times t, where we'll put the first x value as 5 minus 17.8973. So that will give us the first value for our table here. So we'll write the equation for the line, which is 24.6757 times, you can say our values are t here, minus 17.89373. So we'll calculate all of this now for all the different t values given to us, which is 5, 8 and 12. So when we put the t value as 5, we get 105.4812. And then if we put the t value as 8, we'll get here 179.5083. And then inserting the value of t as 12 gives us 278.2111. And now we'll find out the values of the residuals. So that will be taking this value of v here and subtracting the values of these here in the linear line or linear equation. So we'll be subtracting 106.8 minus 105.4812, and that will give us 1.3188 and minus 2.3083, and we'll get here 0.9889. And the next step is to square all of these values, which will give us 1.7392, 5.3282, and then we'll get 0.9779 here, and the summation of all of this will be equal to 8.0453. So that's SR. So we can say that S sub R, or we'll write it here. So this is equal to 8.0453. So as you can see from here, this one here is S sub T, and this value here is S sub R. And now to find out R square, the coefficient of determination, we will subtract S sub T, which is 15027.304, minus S sub t, which is 8.0453, divided by S sub t, which is 15027.304, and this gives us the value as 0.99946. So that means that 99% of the data can be represented by the regression model given to us over here. So this is adequate. The equation is given to us is adequate for the data points that are here.